Hello everyone, my name is Bryce Klink, and this is my relief package drone. Um, so in order to arrive at this design, my first did was I started off with my brainstorming. I had the idea for an emergency relief drone, and then the first thing I did was I started getting into what sort of form that should take. I played around with basically five ideas from the start. Um, And then I also was trying to keep this in mind, what it needs to have, what it is restrained to having. And basically, from all this, I came out with three designs: an amphibious vehicle, a helicopter, and a flying wing. And as you can tell, I was leaning very heavily in the direction of the helicopter. And so I ended up doing three like full-blown sketches trying to figure out the logistics. So I did the flying wing design, the helicopter design, and then an amphibious vehicle, which I just kind of came up with off the top of my head because we needed to have three. But then I started getting through the decision matrix. I lost the original file. I don't know where it went. This is a reconstruction. I basically started weighing all the pros and cons. And something that was very important about this project to me, that wasn't really part of the parameters, but I really wanted it to be realistic. And basically, flying vehicles, by design, they inherently need at least two motors in order to steer, which wasn't going to work within the confines of this project. So I chose the amphibious vehicle because it only needs one motor for steering. I also thought it would be cheap. Um, Maybe the others would have cost more. We'll get to that later, though. The price ended up surprising me, the projected price. But yeah, as you see here, it says one motor for power, one motor for steering, one motor for delivery mechanism. And so that's why I only want one motor for steering. And so I got into sketches. I'm pretty good with visualizing 3D parts and assemblies in my head, but some of these things had to be very specific, and that's when I got out the paper and physically drew it out, did some math. I wanted to make sure I could make all the parts separately, and then they would all just come together very nicely. So I've just kind of recreated some of these drawings where these were just random parts that I was working on at random times. They're not even necessarily part of the same family, but they just happened to all end up on the same paper. And so, yeah, that was kind of my process, is just doing what I can without writing things down, but then when I need to write stuff down, I just wrote it out on paper and then modeled it. And then here are some of the main parts of the drone. We have the main body here. We have one of the clamps that was used to keep the package in place. We have one of the motors. There's three of these identical, one for each function. Then this turning spool, it basically spun, or it rotated a little bit and allowed the clamps to open and close to secure or release the package. And then we have this wheel bracket, which basically was the base for the entire front assembly. And then here is our assembly for the main body, where we have the package relief mechanism, and you can see it hooks up to the motor. So when the motor rotates, it translates the motion through this universal joint into here, and it causes these to get pulled in, which, these are levers, and then on this end is where the package is held in place. So it basically just rotates like 90 degrees in order to release or grip the package. And then this was the front assembly, where we have here without the wheels so you can see it better. This is with the wheels. This is what it looks like on the drone. And we'll take a closer look at this and this later. These were pain. Yeah, so here these are. So this is for the propulsion motor. The motor is attached to this rod. It goes through these bevel gears, gets translated 90 degrees, and then rotates this rod, which is connected to the wheels. And then here is our steering, which apparently wasn't required. I thought it was a requirement until I read the instructions more carefully right before submitting. But anyways, this looks more complicated than it is. It's basically one axle that's connected to this gear, which, causes this, I forget the term for it, but it's like a flattened out gear. It causes it to move side to side, which causes the wheels to turn a bit. And this is basically one axle, but I added 2 universal joints because this gear moves up and down, so the motion had to be able to smoothly translate, or else it would just break itself. And then here is basically our front axles where it's connected to the mechanism, and this is where it would turn side to side. Like this connects to the main bracket. This right here connects to this rod with another universal joint, and it all kind of works. We'll be able to look at it in motion later. And then lastly, I just kind of made the computer chip and the battery. These don't have any real functionality. They're just aesthetic because it's required for the project. And this is my drone fully assembled. It's supposed to be amphibious, so I have these little float pontoons underneath it. You got a better look at them earlier from the underside. And then these wheels are designed to roll on land, but also paddle water. And I thought they would have to be I thought these paddles would have to be curved instead of straight. But then I looked at some water wheels and they actually are straight like this, like those big paddle boats on the Mississippi. Like that's what these wheels are based on. Then one thing that kept happening, what I used for my steering is I basically took this gear piece and I opened it up and I customized it, and it works great, but every time I reopen the document, for some reason it reverts to what it is as a default, even though this is saved as a distinct file, as its own file. So I'm not sure why that is. I'd have to learn a lot more about SolidWorks to figure it out. And so yeah, I just get this error message every time. It looks like this, it's clipping through. So I just have to swap it out for the custom version I made and it's all good. And then this is what it looks like in motion. Hopefully it plays correctly. There we go. Yeah. So the steering is not as smooth as I would like. It kind of has problems. The wheels turn fine. The clamp works perfectly. It worked much better than I ever expected it to. And I didn't have to tinker with the clamp. I just put it together the first time and it worked and it was great. And that was the first and last thing to just work. And so for the cost, I've been pretty behind this semester. I didn't have time to do like a proper cost analysis using the SolidWorks tools. So what I did was I looked up 2 comparable unmanned ground vehicles, UGVs is what they're called apparently. So I looked up 2 of those guys, and I basically I basically used a website in order to take their weight and their price and generate this function. And so I plugged the mass of my robot into that, and I was able to get a price of $33,000, which is really high, much higher than I was expecting. But I would probably be able to make it cheaper because my drone is basically a giant hunk of PVC in the middle. That's the material I set it to in SolidWorks. So I'm sure if we were to build it with actual parts on the inside instead of that, and build it to where it's light enough to go on water, I'm sure it would cost much, much less than this. And then I haven't really done a bill of materials yet, so I just have a list here of all my parts. I have 21 unique parts, 4 supplementary parts, and 2 assemblies. And so, in conclusion, I think I learned a lot from this project. I learned steering systems are very difficult, and if you were to do one that actually functions how it's supposed to, it would be even more difficult. UGVs are expensive, like shockingly expensive, and gears do not work like normal parts. But anyways, that was my whole project. Thank you for listening, and have a good day.